It's now time to look at how to work with these functions on our calculator. So first of all, what we're going to clear the screen, and we're actually going to use the function that we did in the first example a little earlier when we just did it by observation. So to begin, we're going to enter that function, and you probably won't remember, but it's neither of these. I'll just clear these off the screen. And what that function was x cubed minus 5x squared plus 2x minus 1. But it was defined in a restricted domain from -1 to 5. Now, how do you do that? Well, first you're going to enter the function as y1, but you're going to enter it within inside parentheses. So it's going to be open parentheses, and then you're going to have x cubed minus 5x squared plus 2x minus 1. And we'll close that. Now, we close the parentheses, but what we're going to do is we're going to divide it by two mathematical tests. It's a little bit complicated. So what we're going to do is we are going to open a parentheses because this is a fraction. So we'll open the parentheses, and on the bottom of this fraction we're going to actually have a product of expressions. So because we have a product on the bottom, and I know this is complicated, what we'll do is put in another parentheses. Now the interval was from -1 through 5. But the limitations of this calculator mean we can't enter compound intervals. So what we have to do is enter it as a product of simple intervals. So we're going to have -1 is less than or equal to x. Now to get less than or equal to, we hit second and the math button because that gives us test. Less than or equal to is 6. We close that. -1 is less than or equal to x, don't forget the x. We close that, so that's the first of the inequalities, and we multiply that by the second, which was x is less than or equal to, so second test again to get the less than or equal to sign, less than or equal to 5. We close the first parentheses, and remember we had a double parentheses here, so close it again. That's what it looks like. And let's just do a normal zoom on that. So zoom 6. Okay, now that's the graph, and you can see that it's on a restricted domain. It's cut off when x is -1, when x is less than -1, or when x is greater than 5, it's cut off. Now, it is a little bit off center, so what we can do to make it look a little bit better is we can change the viewing window. We can do it in a couple of different ways. First way would be to zoom out, so zoom 3, and let's say we zoom out somewhere about there, halfway along, press enter, and then now it's much too small, but we can draw a box around it, so use the zoom box feature, and let's say what we'll do is we'll draw a box that encompasses all of it. So move to one corner of the box, hit enter, and then move across and down so that your box contains the entire graph. Hit enter again. And now we have a much easier picture to work with. If you remember, what we said previously was that the first thing you want to do is to identify the endpoints and the local max and local min. So what we're going to try and do is we're going to try and get the endpoints, the coordinates of the endpoints. So let's begin with that. Now to get the coordinates of endpoints, something probably that you haven't done before, but to get the coordinates of endpoints, we're going to go second and calc. Remember, anytime you want to analyze a graph, find out information about a graph in your calculator, it's second and calc. That's second and the trace button. So second and calc. Now, to find the value of the endpoints, just hit 1 for value. Now this applies to endpoints. So hit 1 for value, and it asks you to input a value for x. Well, we know the endpoints. We know the x values of the endpoints are -1 and 5. So let's put in -1. And we see that when x is -1, y is -9. So that gives us that endpoint. And if you want to, you can write that down somewhere. I don't have the facility to do it here, but we'll remember it. X is -1, y equals -9. And now do the same thing for the other endpoint. So second calc, choose 1 when we're looking for endpoints. We know the second endpoint occurs when x is 5, so type in 5, and we find that y is 9. Okay, the point that's flashing there, just up here, is hidden a little bit, but it's just up there. Okay, so that's how you find the coordinates of the endpoints. The other thing that you have to find is the coordinates of the local max and the local min. Now, to do that, let's find one at a time. You can only do one at a time, so let's try and find the local min. And this is something you should know already. If you don't know, you really have to go back and learn this. So hopefully this will help you remember what we're doing. So again, trying to find anything from a graph, do second and calc. We're looking for a maximum first, so let's hit 4 for the maximum. The maximum, I don't know if this is going to show up, but the maximum is over here in this area, close to x equals 0. So what we have to do is we have to move our cursor using the left and right buttons, in this case the left button, until we are on the left of the maximum. Okay, now we're pretty close to the maximum there, the relative maximum. Move a few more clicks until you're clearly on the left of it. Hit enter now. Once you've hit enter the first time, return to the maximum or as close as you can to it and move on to the right of it a little bit. Again, hit enter one more time, and when you hit enter a third time, it will tell you that you've got the maximum. The maximum occurs when x is 0.213702, and at that point the y is negative 0.79111793. Now, for AP calculus, we will always round or truncate to give 3 decimal points in our answer. So we have a choice here. We can say that the local maximum is negative 0.791 when x is either 0.213 or 0.214. Okay, and again, you would write that down so that you're going to be able to use it later on for the increasing and decreasing question. Finally, the last thing we're going to do with this is we're going to find the coordinates of the local minimum. So again, anytime we're trying to find anything from a graph on a calculator, it's second and calc. So second and calc. This time we're looking for a minimum, so we choose option 3. We want to move down as close to the minimum as we can possibly get, and we're in that ballpark now. Now, what we have to do is go to the left of it. We haven't pressed enter yet. We must go to the point and then go to the left of it to begin. Once we know that we're definitively on the left of it, we press enter once, move to the point again, and then keep going on to the right a little bit. It's always left first, then right. Hit enter again. It will ask you to guess. Hit enter a third time. And this time we can see that the local minimum is negative 13.06067. And again, to 3 decimal places, that's negative 13.060 or negative 13.061. Either answer is considered correct for the AP exam and for this course. That minimum occurs when x is 3.1196345, which you can write as x equals 3.119 or 3.120. Okay? Once you have all that information, the coordinates of the local maximum, the local minimum, and each of the endpoints, you can answer all the questions that will follow, whether they be on relative max, absolute max, relative min, absolute min, or on increasing or decreasing. We do that just exactly the same. The only difference is that the numbers are now going to be correct to 3 decimal places. Okay, I hope this helps.